Hi everyone. In this video, we are going to take the probability distribution one step further, and we're going to look at a very special type of probability distribution called the binomial probability distribution. And binomial, really all that means is the word bi means two. So that really, it just means that they're probability distributions where there's only two outcomes, not two probabilities, but two outcomes for the event or the experiment, whatever you're doing. So, and those two outcomes, one is considered a success and the other is a failure. Okay, so let's take a look at a question here. This says a realtor has a history of selling 4 out of 10 houses on the market in a month. So that means on average this realtor sells 4 out of 10 houses. This month there are 7 houses on the market. Create a probability distribution table for the number of houses she will sell. Okay, so what does that mean? Create a probability distribution. Okay, well all that means is make a table of the probabilities of all the different things that can happen. So let's close up that question and let's open this up. All right, so here we have, let me add another screen here. Here we have a probability distribution table set up, ready to go. Okay, here is X. This is the discrete random variable of the number of houses sold. Number of houses sold. Okay. And over here I've just defined it. It's the X is the number of houses sold out of 7 on the market. All right. For a probability distribution, we're going to need to look at 4 things. But before we do that, I want to come up with this side right here, this X side. I want to figure out all the different things that can happen. Well, this month there are 7 houses on the market. That means that this realtor, she could possibly sell none of the houses. She could have a very bad year and she could sell 0 houses. That's one of the possible outcomes. All 7 of them don't sell. The other possibility is that 1 house sells and the other 6 don't sell. 2 could sell and 5 could not sell. 3, 4, 5, 6, or in the best case, all 7 houses could sell, meaning she has 0 houses that are left unsold. That would be a great month for her. Right, but there is nothing else that can happen. There are no other possible outcomes to this probability for this month because there is not an 8th house on the market. So this 7 is the most she could sell. But any one of these 8 things could actually happen, any one of them. And each one of them has a probability of happening. We can figure out the probability of her selling no houses. We can figure out the probability of her selling 1 house, and so on. And when we add up all those probabilities, it's going to equal 1, right? Because this is all that can happen, so 100%. One of these things is going to happen. So if you add up all those probabilities, it's going to equal 100%. Okay, so how do we solve a binomial probability distribution? Well, there's 4 things that we need, and I'm going to talk about that now. The first one is the P. Okay, what is P? P is the probability of selling a house. What is the probability that this woman sells a house? And the reason I've put a small case p, all that symbolizes is the probability of a success. And a success we have decided for this problem is selling a house. That's what a success is. All right. So the success is always whatever whatever it is that you've decided your discrete random variable is. All right. So instead of writing the probability of selling, we now denote it with a small letter p. That always means the probability of a success. And if you recall from the previous question, Her average selling is 4 out of 10 houses. Every month, on average, she sells 4 out of 10 houses. So we can say her probability of selling any house is 0.4. 0.40, 40%, however you want to think about it, 40%. All right, she sells a house 40% of the time. All right, so if there is a success, that means there must also be a failure, and we denote a failure by the small case letter Q, and all that means is the probability of the complement, of not selling a house. All right, well, if she sells 4 out of 10 houses, that means the remaining 6 out of 10 do not get sold, and that's the remaining 60%, 0.6. So one thing that's very important to remember with P and Q is that because they are complements, P plus Q will always equal 1. That's really important. They will always equal 1. Okay, then we have N. We have N, which is always your total number of events or your total number of trials. In this case, it's the total number of houses that she could potentially sell. It's always and almost always denotes a total of some sort. So in this problem, what is the total number of houses that she can even potentially sell? It's 7. Okay. And then the final thing that we need to know is we define R, which is just, it is these X's here. It's whichever one you want. R equals the number of successes. Right? So let's say we want to figure out the probability that she doesn't sell any houses. No houses. We're trying to find this number right here. Well, let's think about it logically. The probability that R equals 0, that she doesn't sell any houses, is, well, if you think about it, that means it's 7 failures. It means she doesn't sell the first house, which there's a 0.6 chance of that, times she doesn't sell the second house, all the way down to the 7th. So in other words, it's 0.6 to the 7th power, right? It's 0.67 times because it is actually 7 trials. We have to think of it as every time there's a house. For every house, something has to happen. It either sells or it doesn't sell. All right, so if I just get my calculator here and I do 0.6 and then that caret button, 0.6 to the power of 7, it's going to equal 0.028. I'll round up. All right, so make this a different color here. So the probability that she sells absolutely no houses in that month is 0.28, or roughly about 2.8%. Okay, so hopefully that makes sense. Now we're going to do this. We're going to have the same idea for selling. Let me do this here. Okay, I had to start a new screen because I was running out of space there. But let's think about this next one. And so I've rewrote these numbers over here. So the probability P, which is the probability of a success, which is the probability of selling a house, is 0.4. The Q is 0.6. 7 is the total number of houses that are available, and R is whatever we're solving for. So we just did R equals 0. Right? We can also try the next one, or let's skip 1. We'll jump to 2. Let's figure out the probability that R equals 2. Probability R equals 2. All right, well, that means, remember, we're looking at 7 houses. So if I just go over here, think of it like those letters again. We're going to sell a house, and we're going to sell another house. And then I'm just going to use the letter N for not selling. And we're going to have 5 houses, therefore, that don't sell. Not sell, not sell, not sell, not sell, not sell. Okay, 1, 2, 3, 4, 5. Okay, and remember, unlike this 0 here, which was 7.6 to the power of 7, because there's only one way it can happen. These would have all been n's, and the probability of each of those n's is 0.6. It would have been 0.6 times 0.6. But what happens here? Well, we end up with 2 sales. So the probability, that would be a 0.4 times a 0.4. And then we have the the not selling, which is the 0.6, the probability of a 0.6 times a 0.6 times a 0.6 times a 0.6. Okay, that's the probability of the first 2 selling and the remaining 5 not selling. If we remember from all the work we've been doing on probability, there are 1, 2, 3, 4, 5, 6, 7. So remember, there's 7 factorial ways that this can be arranged, divided by the repeats, which is 2 factorial because there's 2 S's, 2 sales, and 5 houses that do not sell, 5 factorial. And we could work that out on our calculators, except if you look at that, this is 7 choose 2. This is a combination. This is a combination out of the 7 variables, and we choose the 2. We'll just make those the successes. So this is 7 choose 2. It's the same thing. So we have to multiply this by the 7 choose 2. And if you do that on your calculator, maybe you remember, you hit the number 7, and then you hit your probability button, find the N choose CR button, hit that, and then press the button 2 and equals, and you'll see that that equals 21. Right? So the probability, if I change this up, the probability that this realtor sells 2 houses, it is equal to the 7 choose 2 times, she's going to sell 2 houses, so it's that probability of 0.4. And instead of writing it 0.4 times 0.4, I'm just going to square it. That's all an exponent is. It just is how many times you multiply something by itself. And then it's the number of houses that do not sell, which we have 5 of them. Each of those is a probability of 0.6. So there's 0.6, and it's the remaining 5. And if you work all that out, this is going to equal that 21. You just do it on your calculator. 21 times 0.4 squared. And I recommend just hitting the enter button and then multiplying that times 0.6 caret to the 5 and hitting enter. And you'll see that you should get 0.261. 0.261. So there's about a 26% chance that she sells. I'm sorry, let me undo that. We did probability R equals 2. I'm sorry. So this one right here is 0.261. We skipped one. All right, 261. So there's about a 26% chance that she'll sell 2 houses, which makes sense. It makes sense that she'd sell 2 when her average is over here at 40%. Well, what we just did down here, all this fancy multiplying, this is what we call the binomial formula. The binomial formula. And I'm going to just put that back, do that here. This is what we call the binomial formula. And I'm going to write that as, here we go. The binomial formula, or the probability that R equals whatever value you want it to equal, that is going to equal N choose R, N choose R, and you can see down here it was 2. We wanted to find the probability. Whatever here is how many you're choosing, times the probability of a success, P, to the power of R, that's how many successes you want, times Q, and that's the remaining number of houses or whatever it is you're looking at. So it's N minus R. In this case, 5 is the same as 7 minus 2. N minus R is equal to 5 for this problem. Okay, so in other words, these two exponents will always add up to your N, always. Okay, and this is what we call the binomial formula. Okay, and it's just a special formula we have for finding probabilities of a binomial probability distribution. It only works for binomials. And that's because a binomial means you have a success, you have a probability of a success, and you have a probability of a failure. If there are other things that can happen, you can't use this formula. All right, so let's try one more. All right, let's try one more. Let's try to find the probability that that she would sell exactly. Let's do 4 houses. Okay, let's try this one right here. Let's do 4. Oops, Okay, good. So the probability that R will equal 4, we're trying to find out the probability that she will sell exactly 4 houses, is going to equal, and we're just going to use the formula. N, which is 7, that's the 7 houses, choose 4, we're trying to find out how the 4 successes, times P, which is 0.4, to the power of R, which is, in this problem, 4. Okay, in other words, 4 houses, meaning the remaining 3 do not sell, so therefore times Q, which is 0.6, to the power of N minus R, 7 minus 4 is 3. And again, 4 plus 3 is 7. 4 successes, and 3 failures. 4 houses sell, 3 don't. What's the probability of that happening? Well, you punch that all into your calculator, and you might have, if you have any trouble with it, you let me know, but you should get 0.194. There's about a 19% chance that she will sell exactly 4 houses. I don't know why I'm having so much trouble with my pen here. Let's see. 0.119. I can't do it. Well, I'm trying to put it over there in that column, and it's not going. I don't know why I'm always having so much trouble with this. Let me see if I can figure it out. Okay, I'm not entirely sure what's going on, but anyway. So we figured out 3 of the probabilities. We could continue on and figure out the probability she sells exactly 1 house, exactly 3 houses, and so on. And I think you should practice that. And then just remember that those probabilities should all add up to 1. All right. Okay, let's say we are asked to find the mean of this probability. What is the average number of houses we can expect her to sell if there are, in fact, 7 on the market? Well, normally what we would have to do is we would have to make that third column, x times p of x, figure that out and add them up, and that always gives you the mean. But when it is a binomial, probability distribution, it's so much easier than that. And this, we'll just go ahead and I'm going to close those out. And okay, so the mean of a binomial, this is just for binomial, is n times p. How easy is that? All right, which for this problem, n was 7. Remember, we had 7 houses, times p, which was 0.4. And that equals, if you do that on your calculator, 7 times 0.4, which is 2.8. She can expect to sell 2.8 houses. Now, she's not going to sell exactly that, but that's the average. All right, so nice and easy. You just have to remember that formula. And then how do we find the standard deviation? Well, the standard deviation for a binomial, just for a binomial, is equal to the square root of n times p times q. So for this problem, that's going to equal the square root of 7 times the 0.4 times the 0.6. All right. If you do that on your calculator, we get the square root of, remember to do the multiplication first, the square root of 1.68, and that is going to equal 1.29. So she will, 1.30 actually, 1.30 houses. All right. So she can expect to sell 2.8 houses with a standard deviation of 1.3 houses. All right. And then this really ties back into what we learned in the past. Would it be unusual for her to sell 5 houses? Would it be unusual? For her to sell 5 houses? And to remember when things got unusual when they were 2 standard deviations outside of the mean. All right, so if we had a normal distribution curve here, here's the mean at 2.8 houses. This is number of houses. All right. And one standard deviation would be 1.3 above that. So 2.8 plus the 1.3 is equal to 4.1. We have to go one more standard deviation above that. Here's 2. So we're going to add another 1.3, which is equal to 5.4. All right. So this was when things outside of 2 standard deviations on either side. Outside of 2 standard deviations, that's that 5%. So 5 houses would actually be right about here. Boom, 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 5 houses. And that's actually within the normal range. It would be considered a lot. It's above 1 standard deviation. It would not be within the typical range, but it would not be unusual. So the answer to that would be no. Okay, so in summary, let's do all that. Let's do that in summary. In summary, for a binomial probability distribution, we can use to find probabilities of any particular thing happening. We can use the binomial formula, which is the probability that R equals whatever value you want here, the number of successes, the probability she sells 3 houses or 8 or 6 houses or 7 houses, is equal to n, choose R, times the p to the power of R times q to the power of n minus R, where n is equal to the total number of trials that you are having. P is the probability. It's important. P will always be a decimal or a fraction. It's the probability of a success. Therefore, Q is the probability of a failure, and it will always equal 1 minus P. Don't ever forget that. P plus Q equals 1. That's really important. And R is the number of successes that you're looking for. Once you've created your probability distribution, you can also find, even without creating the table, if you want to find the mean of a binomial probability distribution, it's going to equal that n times p. And to find the standard deviation, it's going to be the square root of n times p times q. Okay? You will be given these formulas, but you're really going to want to practice it, and we'll be doing these in class with our M&Ms. All right.